Alright, so it looks like you learned some new functions and how to take their derivative. So previously, all you knew was to take something like x to the n, like x to the fifth or something like that, and you could say that's like 5x to the fourth. And then you learned that the derivative of e to the x was awesome, it was e to the x. And then you learned that the derivative of the ln of x was 1 over x. And now you're learning trig functions, that the derivative of sine is cosine, and that the derivative of cosine is negative sine. And then we can prove that. That's one of the questions you asked. We'll prove that later. But right now, you're just going to kind of memorize it and work with it. Pretty soon in the chapter, they're going to give you the rest of them, tangent and cotangent and all that stuff. So they're just every time you learn a new function, you can add it into your mix, and you can learn how chain rule works for that function, and you could also combine them with product rule and quotient rule. So the most interesting thing is usually chain rule, and so that happens whenever you don't have just an x in there. If you ever have a function sitting inside another function, you're using chain rule. So the way it worked for the ln of x, if you had the ln of blech, right, like if I had the ln of that, the derivative of that would be 1 over the blech, right, 1 over that, but then times the derivative of the blech, of the inside, right? So, so that's how it works for all of these. So now when you're dealing with sine, if you're taking the derivative of the sine of some mess, right, whatever mess you want, the derivative is going to be the cosine of that same mess times the derivative of the mess by chain rule. So that's how chain rule works for these, which is the part that most students get the most confused with. And then the rest of it is just layering that into product rule and quotient rule. So when I do product rule, I forgot what order you like it in, but when I do product rule for these videos, I'm going to do left d right plus right d left, meaning take the left as it is, and then times the derivative of the right, plus the right as it is, times the derivative of the left. You have a lot of options for the order that you do that. So if you do it in a different order, as long as we get the same answer, you're okay. Quotient rule, I'm going to sing the song, the low d high minus high d low, square the bottom, and off we go. And that's the order I like to do them in, because that's how I learned it. So by low, I mean just take the bottom as is, times the derivative of the high, derivative of the top, minus the high as is, times the derivative of the low, and then square the bottom, and off we go. So that's all you need for setup. And then when we go to do the problems, you're just building. So for your first one, we have the quotient rule combined with a little bit of product rule. No chain rule yet, though. So let me write this down here. Sine over x cubed ln x. So we have the derivative sine x over x cubed ln x. Yep. Okay. So here we go. So we have a big quotient. So I'm going to use my quotient rule. And so my quotient rule goes low. So there's the low, times d high, so times the derivative of the high, so times cosine of x, that's our new thing. And then minus high. And then for d low, it's product rule. So we do product rule for the low part. So I'm going to do the product rule for x cubed times ln of x. And that's left d right plus right d left. Excellent. So this was low d high minus high d low, and then we're going to square the bottom, and off we go. So it's product rule embedded within quotient rule. We're not afraid, we just take it as it comes. Now we got to simplify this just a bit. So it's x cubed times the ln of x times the cosine of x minus sine x, and then I'm going to let one of those cancel. Oops, sine x, sorry. And then it's x squared plus 3x squared ln of x, just like that, order better. And I'm just going to keep the bottom. No, I'll make it a x to the 6th and then times the ln of x squared. All right. So you always kind of look for common denominators when you're doing this, or sorry, common factors. If I could pull anything out right away, I would. I'm tempted to pull out an x squared now, but maybe I'll walk it through a little slower just so we don't get lost. So I'm going to actually distribute the sign. So minus x squared sine x. I'm actually kind of distributing a negative sign. So minus x squared sine x minus 3x squared ln x sine x. And then I'm going to pull out the, they all have an x squared in them. So I could cancel an x squared from everybody, but just to, oh, you know what? I'm going to take out the x squared ln x because they, oh, he doesn't have it. Okay, so I'm just going to take out the x squared. And that allows me to cancel that x squared, make that a 4. If you see it, oops, I lost an x. Sorry about that. There's supposed to be an x right there because that was x cubed. So if you saw it here where you can just say, hey, he's x cubed, he's x squared, he's x squared, I'm going to cancel that out and make that a 4 and drop all those down by 2, then go ahead and do it. But if not, if you're afraid of that, which you probably should be a little bit, just factor it out first because that's always safe. Because the only reason we can do that is because it factors. So hopefully, unless I did something silly, this is our final. I'm not going to double check it too much because the process should be okay. But yeah, that's the idea. So let's see what we've got for the next one. Okay, so the trick to this one is realizing when you have the sine to the 4th of x, that's notation that means it's sine of x to the 4th. And that, when we write it like that, the reason we do it, right, sine to the 4th of x, we write it like that to distinguish this, which is what we mean, from this, which is not what we mean. So if you just had the sine of x to the 4th, it's a little confusing which one we're talking about. So that's why we write it there, and that's assumed now or defined to be this one. So I usually rewrite it right away so that I can see my chain rule. I have something being raised to the 4th. So I'm going to have to use chain rule for that part. But first, we have a product, something times something. So we're going to have product rule with a little bit of chain rule embedded in it. Let's see how it goes. So for product rule, I'm going to do left and then d right plus right and then d left. So now here comes my chain rule. So if I have something to the 4th, it's 4 to the 3rd, and then times the derivative of that blickiness, right? Times the derivative of the inside. And there you go. So this is pretty much it. The back of the book will probably clean up the answer. We notice a lot of like terms. We notice they each have sine of x to the 3rd. So I can pull that out. And I can also pull out an x squared from each of them. So when I do that, for this term here, I'll just have the 3 will survive, the x squared got taken out, and then I'll have 1 sine of x left. And then for this part, there'll be the 4 survives, the sine of x cubed got taken out, 2 of the x squared got taken out, so there's an x left, and then there's a cosine of x. And that's as good as that's going to get. There you go. Okay, so yeah, they become kind of fun. So now we have quotient rule, and then when it comes time, I'm going to have a little bit of chain rule when I go to do the derivative of the top. But let's attack quotient rule first. So it's low, and then now d high, so the derivative of the top. If I have something being squared, I'll drop the power, leave the inside the same, drop the power down by 1. So 2 became a 1. And then times the derivative of the inside. So times the derivative of that ln of x is 1 over x. So that was low d high, and then minus high d low, square the bottom, and off we go. So that's that. When I clean it up, there's not a whole lot I can do here. They both have an ln of x in them, so I might pull that out. I might also decide I don't like these double-decker fractions, so I might multiply everybody by x. Let's do that first. So I'm going to multiply the entire top and the entire bottom by x. This is basically a fancy form of 1. And it's going to distribute to this term, this entire chunk here, and knock out that x. That's my plan. So that'll give me just 5x minus 4 times 2, I'll put that in front, times the ln of x, and then that x got zapped. And then when it multiplies by this guy, I'll just get an x in the front, I'll move the 5 in front, and then times the ln of x squared, and then the bottom now gets to be multiplied by x as well. There we go, no more double-decker fractions for us. And then now I'd probably pull out an ln of x from these two guys here. So pulling out that ln of x, that'll leave me with 2 times 5x minus 4 minus 5x, and I'll still have an ln of x, so I don't completely get to do anything really nice. And then I would probably just distribute that and be done. So just say 10x minus 8 minus 5x ln x. And again, I'm not checking these super closely, but I think it's certainly the right idea. Hopefully I'm not losing anything major, but it should be the right idea. Okay. Okay, so again, the trick for this guy is to realize that the sine cubed of x means the sine of x cubed. And so when we write it that way, we can clearly see chain rule. We have something being cubed, so it's be 3 something squared times the derivative of the inside. That's as good as it gets. I'd probably just drop the parentheses, write it a little bit cleaner so that it looks like that. And that's our nicest one yet. Okay, so now for this one, we have a product rule, and within the product rule, we'll have to take the derivative of sine cubed x, which we just did. So when it comes time to take the derivative of that part, we have it ready. But I'll do it again anyway, as if they weren't setting us up for it. But here we go. So we would do product rule, so it's left d right, and so here we go. It's time to take the derivative of the right, which we want to rewrite as that so that I can see my chain rule. So it's the derivative of the outside, so 3 sine x squared times the derivative of the inside, which is the cosine of x, which is the same thing we just got there. So this was left d right, and then plus right d left. There we go. And yeah, and now we're just going to clean it up a little bit, see if I can pull any common factors out. I notice they both have an x cubed, and they both have a sine of x squared. So when I pull it out of this first term, I'll have a 3 that survives and an x. And this got pulled out, but the cosine of x survives, so that guy's taken care of. And then for this term, the 4 survives, the x cubed got taken out, and then one of these sine x's survives. And so yeah, that's that. Oops, I realized I skipped the real number 3. My numbering got off, so sorry. But we'll do it now. So it's chain rule. So it's the outside function is sine, so derivative of sine we now know is cosine. Keep the inside the same and multiply by the derivative of the inside. And so if we just rewrite that, I'd rewrite it like that. And I think she's trying to make the distinction between this and if the squared had been put there, that's different. So this is the answer to our problem. We are done with that. But if it had been this one, it would have been the sine of x squared, in which the outside function would have been something being squared. So we would do that times the derivative of the inside. So we would get that. So just notice the difference of where you put your parentheses and stuff. Okay, so this is an old one. There's no trig in it. So the derivative of e to something is e to that something, and then chain rule times the derivative of that something. And that's it. So we'll write that in a slightly nicer order, and that's as good as that's going to get. Okay, so what this is the proof that the derivative of sine is cosine. And she's doing it from the definition of the derivative, which is the limit as h goes to 0 of f of x plus h minus f of x all over h. So in these you need limits in front of all of them. And so we'll just rewrite it over here. So her first step was if your function is sine, we're going to say that we're going to have the limit of f of x plus h is sine of x plus h. And then we're going to subtract the original function. So we're going to subtract sine of x, because that was what f of x was. And then we're going to throw it all over an h, because that's the definition of the derivative. And so now when we go to actually solve this limit, that's our setup, that's our definition of the derivative with our limit of the difference quotient. And now when we go to solve this, we're going to use, we have the sign of a sum. So all of that trig identities that you learned last year come into play. So remember that the sine of a plus b was the same as the sine of a times the cosine of b plus the sine of b times the cosine of a. So that was your identity. And so now we're going to use that identity to rewrite this. So this is the x is like our a and the h is like our b. So we have the sine of a times the cosine of b plus the sine of b times the cosine of a. So sine x cosine h plus sine h cosine x, which is what she's got right there. And so that was just this part. And then we're still subtracting the sine of x. And we still have it all over h. And so we still have to solve this limit. So this is where you have to be a little bit clever. Early on in the year, we learned that the limit as h, or as, it wasn't an h then, it was just kind of a general, any angle goes to 0, any angle theta goes to 0 of cosine of theta minus 1 over theta, that goes to 0. And we also learned that the limit as theta goes to 0 of sine of theta over theta was 1. So these were things that you memorized a few chapters ago, and we're going to try to find those in what we've got here. So if we cleverly rewrite this, and I'm going to just switch the order of those pieces. So I'm just going to change the order of the top, say sine x cosine h, and then put the minus sine x first, and then plus the sine h cosine x after, because I can add in any order I want. And then I'm going to split these up so that I have the sine x cosine h minus the sine x, put that part over an h, and then plus the sine h cosine of x, oops, all over an h. So I just kind of split it up there, this over the h plus that over the h. So we're used to kind of combining fractions when they have the same denominator, but we can also split them to get two separate fractions. And the reason I do that, again, it helps to kind of know where you're going on this one, because it's like, why would I do that? And that's because when I pull out a sine of x from that, I get cosine h minus 1 over h. And you don't want to drop the limits. If these come up on a test, you really don't want to drop that limit. Teachers like to mark off for that. So we need that written all the way there. And so now we can see that this part, cosine h minus 1 over h, that's just 0. So this is the sine of x times 0. That's really nice. And then this part, sine of theta over theta, sine of h over h, that's just 1. So that's plus 1 times the cosine of x. So that's just plus the cosine of x. And then grand finale, 0 plus the cosine of x is just the cosine of x, which is what we were trying to prove, that the derivative of sine, so if we started off with sine, that his derivative is cosine. Yay! And there it is.